Next on my tiny bench is this beautiful Adcom GCD 750 single tray CD player. The symptom is does not play. Let's turn it on and see what happens. Oh. Open nicely. Strange configuration or figures there. Let's see if it plays. Not quite sure. Let me hook some powered speakers up to it. Be right back. No, it doesn't seem to actually be producing any output. And I'm not sure if you can see. Well, doesn't sound like the mechanism is working, even though got some strange goings on here. All right, next we'll pop the top and take a look at the power supply. Back soon. I just wanted to do a brief overview, top view of the Adcom GCD 750 we've got on the bench. Obviously we've pulled the top off, and what I wanted to point out was just a couple of quick things. I mentioned before that this unit has a unique feature, or not unique, at least rare, in that it has a digital input. So you can connect another CD player to it. Let's say you've got a nice transport, but it doesn't have super hot DAC. You can connect that right to this digitally, and then select on the front panel if you want the digital in or the built-in transport. That's not a real common feature, obviously. It's something I kind of like. It also has HD CD through the PMD 100 chip. And the DAC that it uses are the PCM 1702 per Brown DAC chips. And you see there are 4 of them because it has true balanced output left and right. So one side will create the positive, one side will create the negative. So as I say, it's a true full balanced output. Some CD players and other pieces of gear have a single channel here and then use an op-amp configuration to create a fictitious or fictional negative output. So it gives the impression that it's balanced, but it's not truly balanced. They're not fully balanced like this one is. And you see there are two transformers. One's for the analog section and one's for the digital section. And there are 1, 2, 3, 4, 5, 6, 7 formal full-on regulators, but there are also a couple of other regulators throughout the circuit, and they are denoted with this VR designation. So there's VR 101, VR 102. Those are also voltage regulators. And you'll see, so that's one there, one there, one there, one there, one there, one there. I think that's about it. So, good voltage regulation. Some people like to count the regulators and view it as a sign of quality. So we would say, oh, there's one there that I missed. We'd say if we count the smaller ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 voltage regulators. Not bad. More later. So I'd mentioned in a previous segment that this Adcom GCD 750 has digital in, which is quite unusual. I'm calling it aux here. And so the way this works, the switching mechanism, it has these exclusive NOR gates. And I built a little truth table down here because I work with exclusive OR gates so infrequently that I just couldn't remember, and I thought it'd be easier just to put the truth table right on here. Basically, what it amounts to is we've got these two op amps that have enable pins. And when this is enabled, pin 4, then whatever signal is here is passed through. When pin 12 is enabled, whatever signal is here is passed through. And this is sort of a fancy way of telling this guy and this guy whether to send the digital input or whether to send the built-in transport input to this chip. And then this chip passes it through and passes it through to this chip. And then from there, it goes out to the analog section where it goes ultimately to the DAC chips and then out through the amplifier to the balanced or unbalanced input, depending on, or excuse me, output, depending on what you're using. So I'd also mentioned earlier that this unit has several voltage regulators. So our symptom was that it wouldn't play this signal, wouldn't play this signal, but the transport sounded fine and seemed to be spinning up nicely and real smooth operation. First thing I did was I checked all of the voltages on the main 7 power supply voltage regulators, and they were just spot on. So I started getting curious about this circuit where the switching is done. And what I discovered was this regulator here had its plus 12 coming in, and it's supposed to have 5 coming out. What it did not. It had actually 0, as close to ground as you can get. So the first thing I did, of course, was pull the regulator out, see if it's bad, and it tested fine. So then I started looking at this circuit a little bit, and I mean, if it's showing a true 0, we can see it's probably not caused by these chips, which are also fed by the 5 volts, because there's this 10K resistor. So if there was a short on this side, the 10K would drop some voltage and we'd see something here other than 0. I also checked, of course, these two capacitors, make sure they were not shorted, and they were not. That pretty much left this as a very suspect chip, U106, because that is fed directly from this regulator. So almost everything else has a nice big resistor ahead of it. So for example, if the short was over on this side, we would see a voltage dropped across this 10K resistor, just like I said before here with this 10K. So once we determined it's most likely not these capacitors, I started looking at this chip. And there was really no easy way to isolate or determine if it was that chip or if it might be something else. So I started thinking probably best bet is to just replace that chip and see if that cures it. But I started looking around a little bit more, and I noticed that what this produces is called plus VD. Plus VD is also fed up here, but again, we got these two big resistors. So if there was a short on the other side of here or here, we would have some voltage. It wouldn't be 0. And then I also saw that we had plus VD here, which seems to be a direct feed without any big resistor. So U107 or U106 were the culprits. And just to make sure that the voltage regulator itself wasn't somehow breaking down in circuit, under load, I went ahead and I swapped out this chip, and this regulator. And sure enough, now we've got plus 5 here, and the unit works fine. And it easily switches between the auxiliary and the built-in transport. So, next video, I'll just show the unit in operation briefly, but she's up and running, sounding great. One other quick thing I wanted to point out is, I don't know if you can see it over here, bear with me. I wrote for Adcom, and they were kind enough to share part of their schematics service manual with me. And what I noticed was this unit was manufactured by California Audio Labs. So, which is, or it was, just a really good audiophile level CD player company. They're no longer in business, unfortunately, but I think that speaks to the pedigree of this unit. Okay, more later. Here we are once again with the made by California Audio Labs, but wearing the Adcom GCD 750 badge. And we'll just watch how, let me open and close it so you can see how quickly she reads the disc. Boom, 8 tracks, play. Just starts that quickly. And of course, we're listening to royalty-free music, because the best music is royalty-free music. And again, you just see how quickly she spins up and plays. And that's it from my tiny bench for this session. More later.